In this Leetcode problem, we are given n bulbs. Let's take 6 in our example. And the problem is to run a loop for n times. In each iteration, we toggle every nth bulb on or off. So in the first round, we toggle every first bulb. Here, it will be every bulb position that is one step away from the previous, so all the bulbs. Then in the second round, we toggle every second bulb. So here it will be second, fourth and sixth. Then in round 3, we toggle every third bulb. In round 4, every fourth bulb, and the same goes up to n times, which is 6 here. Now, after all these togglings, we have to find out how many bulbs are on. Here only 2 are on, so our answer will be 2. Now pause the video and try to find the underlying pattern and solve this problem yourself. So, the bulb is off initially. If we toggle it once, it will be turned on. If we toggle it again, it will be turned off, and so on. Now the observed pattern from this is that if we toggle a bulb an even number of times, it will be off at the end. But if we toggle it an odd number of times, the bulb will be on at the end. So the problem basically is to find which numbers have an odd number of divisors. And if we start looking at the pattern starting from 1 and all the way up, we can clearly see that only those numbers have an odd number of divisors that are perfect squares like 1, 4, 9 and so on. So the final solution is basically to find out how many perfect squares are in n numbers. And to find that, we simply take the floor of the square root of n. So here for our example, n was 6. Taking the square root of 6 and then taking the floor gives the answer 2. And the code is super simple. Just return the int of square root of n. This will give the number of perfect squares in n. So we submit this and yeah. And if you look at the time complexity, it's constant time because there is only one calculation needed. The space complexity is also constant because no extra memory was required.